Welcome to the latest episode of the MFG Radio Network's Lunch and Learn, as we highlight some of the latest advances in manufacturing and design, gain insights about the newest products and technologies to move your manufacturing ahead of the competition.
Hello, I'm Elizabeth Modick, Editorial Director of GIE Media's manufacturing group of magazines, which consists of aerospace manufacturing and design, today's medical developments, EV design and manufacturing, and our newest publication and website, Defense and Munitions. Today, you will hear from Jason Atkins. He's the Business Development Manager with Fastems, and he will explain how to unleash the full potential of your manufacturing with Fastems robotics solutions for part handling. Fastems supplies intelligent automation and digitalization solutions for high-mix, low-volume CNC manufacturing. Fastems is an open integrator and a family-owned business with 40 years of automation experience, more than 4,000 installations in main markets in Europe, North America, and Asia. Fastems' mission is to help metalworking manufacturers improve their productivity and profitability. Fastems' main application fields are pallet and robotic automation, always equipped with Fastems' industry-leading production planning and execution software, MMS. And Fastems also has solutions for automating the production and resource planning of standalone machine tools. Fastems supports their systems with a wide range of services. Now, a little bit about your presenter. Jason brings more than 20 years of direct manufacturing experience to his role at Fastems. Atkins gained firsthand knowledge of the needs of the machine shop early on as a machinist, eventually becoming an NC engineering and operations management. Becoming an NC programmer and manufacturing engineer before moving into manufacturing engineering and operations management. He has spent the last 15 years involved in aerospace manufacturing and is responsible for 2 sizable installations of Fastems automation systems at aerospace manufacturing shops. Atkins is well practiced in performing and managing manufacturing process improvements and in implementing manufacturing best practices and manufacturing automation systems. Jason, the platform is all yours.
Thank you. I'm glad to be here today and glad that I can share a little bit about Fastems robotic solutions for part handling and auxiliary processes with everyone. Fastems is known predominantly as a pallet automation provider, but we also do many solutions and provide many solutions for part handling solutions focused on mill turn machines, lathes, as well as auxiliary processes. So we're going to get into some of that today and hopefully can provide some valuable information for everyone that is here attending. So to start, the first thing that we try here at Fastems to answer is our typical questions that I think most of us in manufacturing have, which is to start, how do I plan and manage my production while my demand changes? And does everyone in production know what to do at all times? Do you have visibility? When should I start this batch or work piece on the machining center? If you don't start on time, you can't finish on time. So everyone needs to know when to start. And do I have the needed resources? Are they in effective use? Whether it's tooling, whether it's work holding, raw material, NC programs, do I have everything I needed when I need it? How much WIP and stock do I have? As we all know, that affects our bottom line as much or more than most other things. So WIP and stock is very important, and it's good to have visibility on how much the company has or you have at all times. Do I know what's happening at all times? Can I track it? Can I get the data? Can I deliver the quality and required quality and be profitable, which is most important because it's hard to stay in business if we're not making any money. And so we always at Fastems try to answer the big question to us, which is, what if my production would do only the right things at the right time all the time? And we feel if we can solve this problem, then everything runs a whole lot smoother. And that is during all 8,760 hours of the year. How do we maximize our utilization? So outside of our pallet business and pallet handling solutions, we also have robotic solutions and machine tending solutions for order-driven flexible batch size in your production. So all of this is still controlled all by MMS. We have multiple different products that we want to cover today. Within our machine tending solutions, we have our RoboCell 1, which is a standard product for us. It's a robot cell for 1 to 2 machine tools with a relatively standard footprint for those machine tools. It is agnostic to machine tools, like all of our Fastems products. We can hook to any machines, but these are specific. This cell is specifically designed for predominantly mill-turn machines or lathes that requires a robot to handle the part itself outside of a pallet system. So we're doing direct part handling. And then this is for, like I said, either 1 or 2 machines. 2 machines is the maximum. We also have an agile manufacturing cell, which is modular, which is also designed for part handling and for lathes and mill-turn machines, with the possibilities for ancillary or auxiliary processes like shuttle storage or hooking up a CMM for metrology, parts washing, other things, deburring that we need to do outside of just tending the machine tool. So a much more integrated automation and robotic solution, and it has no layout limitations. So we can tailor the system and customize it to fit your needs in your production environment. And then stepping up from there, we have our full agile manufacturing system, which is a complete customized solution, combining multiple Fastems automation solutions, all integrated as one system, whether it be multiple FMS systems, an AMC agile manufacturing cell, RoboCell ones. We can put all of those systems together as one and integrate them as one system, one solution controlled by one software platform, which is our MMS software. In addition, we also have value add and complementary robot solutions, which we can integrate within systems, or we can do a standalones, like our robotized finishing cell, which is a robot cell for deburring and finishing applications. It's a secondary process, usually done with people. We can do that with a robot. We can put that as a finishing cell, like I said, as a standalone, or we can also integrate that within an FMS system. We also have our GTS, CTS tool automation products, which is a gantry tool service system or a centralized tool service system, which is for cutting tool automation across multiple machine tools. So the operators do not have to stop the machine and introduce new cutting tools to the machines through the tool magazines, or take spent tools out through the tool magazines. So all of the tools can stay in one location in a tool hive, and then have a robot take the tools to the machines as needed. We also have our auto loading cell, which is usually implemented within our FMS system, which is an integrated cell for automated loading of machining fixtures. So instead of having operators taking off, loading machining fixtures, work holding parts into work holding, we can automate that through an ALD cell and have a robot do the changeovers for you. And then to complement these systems, we also have our services and offline programming. We do offer our robotic deburring services, which is process verification for automating our customers' deburring process, where we can help you out with that and verify it before that we implement the robot deburring solution. We also offer our offline programming software, which is proprietary. It is for simulation and visualization of the deburring and finishing operations, which you can do that programming offline instead of programming it with the robot and having the robot out of service while you're doing so. So we're often asked why Fastems automation solutions are different. So we're more than just robot loading. We offer fully integrated robotic solutions. We have guaranteed unmanned periods. We can track that data and that metric through our MMS software. It's also, we try to make it very easy to operate, and our robotics in general are usually a scary thing if you haven't implemented those before. How do I do this? Do I need a lot of training, robotic technicians? This is going to be very complex. There's going to be, a lot of cost involved in it, into it. A long period of ramp up time before I see ROI. So we try to make this as easy as possible and deliver more of a turnkey robotic solution for our customers. And then long-term productivity, MMS and our platform is under constant improvement. All of our systems, we're striving to constantly improve those. That way we deliver the most value to our customers. And then we also have years of experience, 40 years of automation and implementing these solutions across multiple different customers, multiple different types of machine tools and automation solutions. So with MMS, I do want to highlight that really fast. Within this, all of our direct part handling is also controlled by MMS, the same basic software as our pallet handling products, but also custom tailored to the needs of direct part handling, which also has our standard intuitive user interface, easy integration of different production machinery and data systems, all tied together with MMS and our software, easy introduction of new work pieces, which is fully designed to minimize the need for robot programming to make it easier for you as the customer. And then our predictive production scheduling and resource management, which is required for flexible and efficient batch production in a high mix, low volume environment. We have to be able to see our resources to be able to properly schedule our production and also be able to predict what's going to happen in the future. So we know as manufacturers that we can provide those resources to the system before the system stops, which is very crucial for maintaining your machine tool utilization. So flexible batch production with MMS is all based on real production orders and their due dates, which is how it works. We schedule the job automatically to the machines based on production orders and their priorities. We only were looking to produce those parts that are really needed, whether it's one at a time, 5 at a time, 10 at a time, but true just-in-time production. And we also want to inform the user about upcoming cutting tool or material shortages in advance to eliminate spindle stoppages. And also to reduce setup time changes, which we also take into account in the scheduling. A lot of times when you're only working through an ERP scheduling system, we miss those setup time changes because they're not calculated. It's only calculating the time for the part itself. And so you're always coming up short on your schedule. And so how does intelligent automation make more money? Higher profits through lower unit cost, and higher return on capital, with lower work in process, minimize stock levels, more satisfied customers with high and stable quality, short and reliable lead times. You can produce when they need it, and they're not paying the extra cost associated. But with the lead times, they get things on time, which I think makes most customers the happiest. Higher revenues for our customers through higher output, transparent capacity availability, excellence in operations, full flexibility, more integrated processes, less setup times, more unmanned production hours, which I think everyone would be happier with, and we're all looking for in manufacturing. Easier employment, meaningful work. People are able to learn more things, learn new skills, and have some fun. I haven't met very many people that do not have fun with robots in manufacturing. A little bit more safety as well, where we can keep certain processes behind a fence. We can keep a robot doing those tasks that are your more unsafe tasks that produce a safety risk to your employees. And then quickly, and just want to go through a few solutions really fast before we end our presentation today, on what kind of solutions have we at Fastems delivered recently with our robotic and our auxiliary processes, and how do we automate those? So with machine tending solutions, we have RoboCell 1 application. This was to automate the manufacturing of 2 different product families, each with several different product variants. Workpiece weights were up to around 30 kilograms, with 2 different machine tools. The one machine tool was already in existence, which was the Index G220 mill turn machine. And then our customer decided to add a Morisiki NT4300 mill turn machine as well, and wanted to automate both with one system, which is specifically what this RoboCell 1 product is designed for, and it does very well. So we were able to solve this problem with the customer and automate both of their machines through these 2 different product families and their variants. We also have a gripper chain system on this. Both grippers are manually adjustable. Also has, MMS control, obviously, with NC program select and start. And so the task on this one was simultaneously running of 2 different part families in varying batch sizes, flexible handling of heavier work pieces. System downtime needs to be minimized during new part introduction, and leaving working space between the machine tool and the cell to service the tool magazines, and to carry out maintenance or prototype runs without sacrificing automated operation on the other machine tool. So we were able to do this with the RoboCell 1 product by employing the KUKA robot, and having the machine tools being able to run on can be separated and isolated from that automated cycle, so they can get in there and actually prototype if they need to without affecting the total system utilization. And so we also do work with our customers to solve the problems on how do we handle all of these different parts. And so we have a customer case where they needed 35 different cast iron parts in total. how do they do this? So we worked with them on developing a gripping solution and to handle their required amount of parts within the system without having continuous gripper changes, which affects the downtime of the robot itself and the total system availability. So we were able to help them solve this with their gripper concept system. And then I do want to show an AMC quick example. This is a larger case, but kind of just want to show kind of what this would look like with more of an integrated system. So this case, it has a mill-turn machining center, a family of 11 cast iron raw materials, which the customer makes from 19 different end products. So they needed a way to have a high mix, low volume system that was also able to do more than just machine tint. So we set this system up to also have tower storage, to also have a blow cabinet, a measuring machine, and a washing machine. So the parts after they're finished machining, they could be washed, they could be dried, and they can also be measured on the CMM and then put in the storage tower to take out whenever that they need it. So much more of a fully integrated robotic solution that does more than just standard machine tending, but all aspects of this system scheduling are all still ran through our MMS software as one system. So much easier to schedule and run your production. So this system had small batch production down to batch sizes of 5. They needed to run over the weekend. That was one of their main requirements. They also need to load the parts for 2 material bins for subsequent assembly phases. And then the system needs to have inline measurement of parts as the system runs, more of a one-piece flow. So this system turned out really well. And we were able to solve this for our customer using a robotic solution. I'm going to skip that one because we're getting short on time. And then with this one, I just wanted to highlight very quickly. And it's not just about in this system, what made this really work. It wasn't just about the machine tending itself. We also had to solve the problem of multiple different parts required multiple different gripping systems. So we had to put in a gripper rack where we're also changing out the end of arm tooling on the robot automatically. And then the robot itself is also being used to change out the chuck jaws within the machine to do chuck jaw changes and fixture changeovers to allow this system to run unattended. So the robot, to highlight, can be used for more things than just the machine tending aspect. We're also using it to do the setup changes within the machine tool itself on the spindle chuck. And then when we talk about value-added solutions, we have auto loading cells to automatically load fixtures before they go into the machine. This case, you have near net shape forgings. They all needed to be loaded onto fixturing, which takes a lot of time for a person. It also becomes unsafe, smash fingers, cuts, scrapes, that sort of thing. So we set up an auto loading cell to automatically take those near net forgings and introduce them and to the system, to the work holding, and reduce the amount of part handling by people, which is more complex than I can explain very quickly. There was a lot to that. We're also doing deburring within this auto loading cell, chamfering within this auto loading cell to prep the work holding or the parts before they go on the work holding, and also deburr after they come off the work holding. And then also just wanted to highlight during this presentation our robot finishing cells, which can also be done as a standalone unit. They do not have to be integrated in with our inside of a larger system, an FMS system, whether it be pallet or robot. We can do these just as a standalone unit if you have a deburring case where um, um, you want to automate that deburring application. So with the robot finishing cells, we can set those up, multiple end of arm tooling. We can also have uh, servo driven tables for high accuracy. Our robots, we can use pneumatic or spindle servo driven spindles, also for accuracy and spindle torque. So, multiple spindle changeovers where we're using the robot as a more of a machine tool with a rotating spindle and can do multiple tools for the end of arm tooling to cover a very large range of part sizes and deburring needs. And so this just details about, this particular cell. We were using robot servos for maximum freedom for robot programming for the deburring process. We have electric spindles on this one, which have different torque and RPM ranges, which differ quite a bit from the pneumatic solution. So we can do slow speed solutions, high speed solutions for multiple different deburring applications. And then a question that we're asked a lot, which is the reason I included this particular system on here. Do you have a fire suppression system in the cell? And we get asked this question a lot because dust can be very flammable depending on the materials. So we don't want to have explosions. And so a halogen fire suppression system can be included very easily within the system to suffocate a flame out, or if you have some sort of, if you're deburring some sort of flammable material, especially something like magnesium or titanium or something that you're creating some very flammable dust. And then we can also combine these in a robot finishing cell with an auto loading station. So we can auto load the parts within the system. Back to the original question, what if my production would do only the right things at the right time, all the time, and through all 8,760 hours in the year? So, if any of these systems can help you do that, then contact us. For more information, you can shoot me an email, call me on the phone, and I will be glad to discuss any of these solutions more in depth. So thank you everyone for your time.
Jason, thank you for that great presentation. And we do have a few minutes that we can take some questions. So our first question is from Jason, for Jason.
Awesome.
For the RoboCell example, what was the cost of order of magnitude, less the machine tools, and the lead time for the implementation for the project?
I don't have the cost numbers for that exact system in front of me at this time. I can easily provide those if email me and I can easily get you those numbers later. Lead time on those systems are actually pretty short in comparison because it is more of a modular product. But our lead times are usually based on at the time of order. So I don't know exactly the lead time on that particular system. Standard lead time on a system like that is probably going to be in the neighborhood of 16 plus weeks on average. They're not going to be in stock specifically for the end of arm solutions because those are going to be very specific and very customized to the product that you're making. So for all part handling, that's usually our longest lead time is defining how we are gripping the components and coming up with that solution for part handling because it always is customized to the individual customer.
Great. And another question for you, Jason. How important is it to partner with your automation integrator at the beginning, starting from square one?
It's very important. The earlier that you're partnering with your automation integrator, the more information that you can work together on between each other to develop the right solution that fits you very well as the customer, I think is very important. Um, if you're waiting until, it's crunch time, and then you're trying to rush everything and trying to just get something as fast as possible, I don't think that you're going to end up with the best solution for your application when it comes to the automation. So the earlier you can partner with your automation integrator of choice within your projects, I think that is most important to getting the best solution that you can for your application.
Perfect. And we're going to sneak one more question in here. Can you give a brief example of a customer who was able to successfully adopt automation for their part handling operation, and how fast were they able to see the change?
I probably can't give a very specific example right off the top of my head um, um, of a customer and a system and an ROI period. So, um, you know, we have multiple
Everything varies.
well, yeah, but we have multiple part handling cases with multiple customers, and some were allowed to share and some were not allowed to share. So I don't want to pick one right off the top of my head and then speak incorrectly about it, right? So, but like I said, if anybody wants specific examples with specific numbers, contact me and I will be glad to share as much information as possible with you.
Wonderful. Jason, thank you for the great presentation and answers to these questions. And before we go, just want to remind everyone that you can find all of our upcoming webinars on any of our websites, todaysmedicaldevelopments.com, aerospacemanufacturinganddesign.com, defenseandmunitions.com, and evdesignandmanufacturing.com. And don't forget to reach out to Jason with any questions. I hope everyone has a good day. Thank you.
You can find more Lunch and Learns plus the MFG Radio Network's other podcasts on Apple Music, Spotify, Google Podcasts, or on our websites at todaysmedicaldevelopments.com, aerospacemanufacturinganddesign.com, and evdesignandmanufacturing.com.